Okay. All right, there we go. So I am going to hand it over to Shonda.
And I think you have to stop sharing your screen first.
Yes, there
Okay.
I did. And all these fun technology things.
Okay, you should be seeing my screen now.
Yes, I see it.
There we go. Okay, well, I'm excited. This is the first time I'm officially presenting this site and the work that we're doing. And I really think it has great potential to change the way we think about teaching intro stats. I was listening to a lot of the other AMATYC webinars talking about, the need for active learning and the need to create places where students are asking questions about data instead of just simply doing calculations. And I think this is an approach that I've been taking in my classes that's been working fairly well. So it is data space. I have to move this so I can read my own slides. It's a website that's freely available to everyone that includes interactive, interdisciplinary stories and data journalism pieces, but it also incorporates a lot of pedagogical tools that are interactive and encourages group work and encourages students to think about an intro stats class as how do I answer questions or make data-based decisions. It has several aspects to it, but the one I want to focus on today is a place for educators to ease the difficulty that students have in adjusting from traditional homework to real-world case studies. And I know that's something, especially in two-year colleges, that's really, really hard to do. And so what we've done is we've focused on making these things as easy as possible for educators, meaning we have auto-graded questions, we have apps and very clearly guided questions so we hope students can do a lot of this without requiring instructors to put in a significant amount of extra work to get students to think about data differently. So we have a lot of data visualizations that really help students think about data decision-making just using a visualization. Our first example is going to focus on that. We also have interactive apps that have guided questions so that students know exactly which step to take in each step of the statistical analysis. We also encourage students to ask unique questions about the data. As Chris Franklin said, what she likes to say, when you see a graph, what do you notice? What do you wonder? And then students can just immediately go to the data and get answers to the questions that they're interested in asking. We have quite a few discussion questions that are optional for instructors to include that really get students to think about the data somewhat differently. Some of those discussion questions include little competitions or games and activities that seem to get students excited about the course in new ways, engaged in new ways. And we've intentionally broken up each one of our stories into 1 to 3 parts, where the first part is meant to be accessible to high school levels, where the more advanced questions could be, graduate level research projects. But the first page of each site is intended to be fairly accessible at all levels and should be able to be used. And then we also have a repository of clean and easily accessible data for additional research projects. So why did we create this? Well, one of the things we wanted to do was we wanted to create examples that felt real to the students. Student data where students actually take ownership of their work. Gould talks about this in some of his papers, and the importance of finding patterns that matter and finding deeper meaning and insights so that better decisions can be made. We want to encourage critical thinking with the data, addressing common misunderstandings, talking about bias, conditional probabilities, assumptions, abstraction. Okay, here's the calculation, but how do you go beyond that calculation? How do you go beyond the thoughts of what's just, in the guided questions? Those are things that are often very difficult to teach in a traditional textbook that we hope using these interactive apps and simulations might make it easier for students to understand these ideas. And as the curriculum guidelines stated, we want to go from a small, carefully vetted data sets to asking more complex questions and making real, meaningful decisions with the data. And also, we want to focus on the importance of active learning, in getting deep engagement and peer-to-peer learning in these groups. So one of the key things I hope you see as we try this is that students have a sense of ownership for the decisions they make. They're going to be able to, they're going to have to state, well, not only the p-value is less than 0.05, so we reject. No, we have to say, well, based on the hypothesis test, I'm going to make the decision to make this purchase, which is a very different thing. Students, that sense of ownership and the decision-making goes past just like, well, is a p-value small or large? Really forcing them to think about the interpretation in very unique ways that are different than what we've seen in a lot of traditional textbook questions. And challenge students to think carefully about data and the models. What models do they choose? And again, so what we're trying to do is we're focusing on the calculations, but we also want to focus on the interpretation of the numbers, not just the calculations. And one of my favorite quotes is, learning is essentially hard, but it happens best when one is deeply engaged in hard and challenging activities. So how do we get students, there's this phrase called hard fun. When students are having fun, if you're playing a game or an activity, you want it to be challenging. If it's too easy, it's no fun. But when we talk about homework and class assignments, students always want it to be easy. So how do we get them to want to be challenged in a new way? And I think that's one of the things we're trying to approach with this, is getting students to engage in the challenge that we give them through these data journalism articles and games. So today I'm going to try to go through two examples. One is a game that I'm going to just introduce fairly quickly, give you a chance to play. It's more of a simulation, but you can see where the game aspect would come into it. And then one is a story about New York Police Department discrimination data. And then I will have you access my website and you can see how these activities could be incorporated into your classes. So the greenhouse game is an online environment that simulates a greenhouse. So, as a player, you can buy seeds, you can plant crops, you can harvest the crops, and then you sell the crops. We start out with level 1 on this greenhouse game. And in this level 1, students only need to worry about water. So we say the only crop we're going to grow is corn. And the only variable that you need to really worry about as an explanatory variable is the amount of water to give that corn. And is there a relationship between water and the yield of the corn? And so, this is really the concept behind these games. Anyone can play these games, and you don't need any statistical background to win. However, you are more likely to profit and earn more money, win the game, if they use interactive graphs and statistical models to improve their strategies. So when we play this game, there's some key terms that you need to know. The first is yield. If you're a farmer, I'm in Iowa now. I grew up on an Iowa farm. So yield is the amount of crops produced on a particular plot of land. And we still measure the yield in terms of bushels per acre, typically. So what we're doing is in each plot of land, we're going to look at how many bushels were produced, and that is our yield. Our yield is measured in bushels that were produced. We also are looking at an explanatory variable with water, and that's the number of inches of water that you add. Like, so when you talk about rain, if you say you got 1 inch of rain today, that's 1 inch, of water that was assigned to that plot. So we're going to say water is measured in inches as you work through this game. So as we work through this, one of the things I'm going to ask you to do is I want you to start by estimating the corn yield based upon the amount of water. And I give all students a starting point. So on the website, you'll be asked to input a player ID. So all of you, I hope you'll take a minute and you'll think about a player ID that you could use. It can be, it doesn't, and again, since it's on the internet, we don't want it to identify you. It's just any alphanumeric code. And then everyone is going to put in exactly the same group ID, which is AMATYC 1. And then to measure water, the first thing we do is we select level 1. We select the crop corn. We select water amounts. And so we put in 10 inches of rain, 15, 20, 25, 30, 35. And then you can see, here's the things that we're going to select throughout the game. We do have an online video tutorial that walks through this, in about 5 minutes, so that students you can show this in a class if you don't feel comfortable demonstrating it yourself. But usually what I have instructors do is kind of demonstrate the game, and I will do that for you in a minute, and then have the students collect their own data. After you select those variables, you can move the cursor over each plot and identify the type of crop and the water that was received. You can harvest the crops, and then you can sell the crops. And it will tell you how much profit you made, if you made a profit. After you have harvested and sold all your crops, enter your data in the forms that are provided below. And so right below the game, we have this interactive app. And so if you used in apps before from our Shiny, this is built, but right now we're selecting water and yield, but you can change that Y variable, and we can create different models. We can create a linear model, we can create a quadratic model, and we can also change the X-axis limits. So we have these online interactive visualizations built right into the page where students enter their name and their instructor email. And then there's a series of questions that are automatically graded. So instructors can go in, and then once you do this, you can go to another website, pull data by your email and your password that you use, and you can see if students answered these questions right. Like, what is the proper linear regression model? You know, what is the slope? What is the correlation? What does the correlate? Things like this, just basic questions. After they ask basic questions, there's more challenging questions, discussion questions at the end. So at first, they're using a standard data set. It's a sample data set. It's not your class data. It's just a sample data set so that everyone gets exactly the same answer. We know what the slope is. We know what the line is. So those things can be auto-graded. But then students get a chance to look at their own data and interpret their own data. And then they're asked, how would you optimize profits for corn in level 1? And they're really looking at, do I want to use a linear regression model to optimize that? Would a quadratic model work better? And even if they don't know the terms for quadratic, they can still just look at the graph and where does it look like it's optimized? So we give students a challenge. You go back into the game, play the game again, slightly change your group ID. And just by changing your group ID a little bit, play one more time and see if you can make the most profit in one season with this new group ID and the same player ID you did before. Any questions on that so far? Am I getting?
I don't see anything in the chat.
Okay.
And so I think you're good.
Okay. So here's the website, and I'm going to share the link with you very quickly. But in this website, you know, here's the introduction. We talked about the yield, bushel, water, you know, how to input a player ID and a group ID. Remember, your group ID is AMATYC 1. Capitalization doesn't matter. Here's the instructions on what to input. So right in here, I'm going to select, if I go to this game here, I'm going to put in here. Let me refresh the page real quickly. And so then I'm going to select a level here. I'm going to select level 1. The tutorial's right here. It will go to a YouTube video that has a tutorial. And this gives an instruction, like how much we have to pay for each crop and costs. We're not going to focus on that, you know, carefully right now. So we can go ahead and hit play. And now I have to just select these options, corn, and input my variables just like this. Once that's done, you know, actually, let me just give you a quick example, I think. 10, 15, 20, 25, 30, and 35. And so we have up to 40 plots. So if I want to test every combination 5 times, I have 6 combinations, you know, corn with 10 inches of water, corn with 15 inches of water. I want to do 5 plots with each one of these combinations. That requires 30 plots. And it will cost me, based on the calculations on the previous page, $1,575 to do this planting. I started out with $5,000, so I have plenty of money left. I can manually assign crops, but I'm just going to go to randomize play. And what it does, here's my corn, and I can highlight over each one of these, and the outlines indicates the amount of water. So this is 30 water. The darker the outline, the more water it had. You know, here's a lighter one. It had 15 inches of water, but I planted corn. You notice nitrate is fixed in this level. Every plot has 350 pounds of nitrate within the water. Okay, so I can see with that how much grew in these. So this one had 10 inches of water and it only grew 5 bushels. This is a darker one. It had 30 inches of water and grew 19 bushels of corn. So I'm going to harvest this. I'm going to sell it. And so I made $64. I was able to sell the corn. I think it sells at $4 a bushel. So totally, I made just a little bit of money. So now I have this for the first season. So my goal obviously is trying to make more data. One way I can do that is look at this graph here, which shows my data. And if I look at it here, you know, I can kind of get a good picture of what it looks like, you know, how much yield is, you know, being produced, you know, where am I producing the most corn? But you may not be interested in yield, you may be interested in profits or something else. So you could change it here. You could look at different things, you know, like nitrate level. Ooh, oh, that's plot. So every plot, you can see I planted 30 plots. This is what I get. I can look at nitrate level. Every plant, you know, had 350 nitrates, and it varied from, you know, about 4 bushels per acre to over 20 bushels per acre. Which plot is the best one that helps me determine how to optimize my income? So right now, I'm going to go back. That data gets automatically stored in the data set so students can look at their data. But before we do that, students have this sample data to look at. So what I'm going to do is I'm going to go into chat here real quickly. If I can find chat. Oh, and so when we say 5 inches of water, we're saying it's 5 inches over, over the entire season. So it's not like over day one. So a season is usually like 3 months. So I'm going to type my message. So in the chat, you can see a link that should bring you to this site, and you should be able to do exactly what I did, which is just play the game under these conditions. And then we will look for your individual data later on and talk about what we can decide or what we can do with that, what decisions we can make. So I'm going to give people about 3-4 minutes to do that. And please type your questions in. Mary or I will do our best to answer those as you go. So just keep on looking at that. So
I'm going to go play the game too. So
great. And keep track. Remember, before you quit the season 1, keep track of how much you earned, because that's going to be asked in the game. And my instructor email is Kuiper, so you can use that for this AMATYC class. So when it asks for the instructor email. And again, this would be graded if you want to complete all this. You don't need to submit all these answers for all these questions. Okay, going to give you about 1 more minute. If you need more time than that, put it in chat. If you're done, just go ahead and start playing around with the app and seeing what you can find. The first time you log into this site, it can take a little while. So if it's taking a while to load, afterwards, it will load more quickly. It sets up some cookies on the site to make sure it works. So it takes just a little while to get the page loaded the first time. Often I just demonstrate in my class, and I have students do this outside of class, so there's plenty of time. The students don't feel rushed to complete it in class. They can follow these instructions fairly well. They just need to input their data in. And if they input it incorrectly, we adjust for that later on. So it's perfectly okay. It's a nice way to have an outside of class activity that students can just collect their data outside of class, and then we can come into class and discuss it. Somebody lost a little money. So I won, so how if we put exactly the same thing in, why are some people winning and some people losing if they're using the same variables? Okay. Mary, did you finish inputting your data? Okay, great. Okay, so with this, and there are questions on the side. And so here's one question that we have for you. And this is in a poll as well. There's 2 greenhouse polls that you can look at, and I'd like you to answer those questions. So Mary, if you would be willing to share those 2 poll questions. And so that we know that, here we go. So go ahead and you can look at your app and play around with these to see if you can answer these 2 questions.
So I'm actually going to read the questions because sometimes the recording does not catch them. So the first question is, after growing the corn, the farmer sold the corn for $4 a bushel. Thus revenue was equal to 4 times the yield. If we use revenue instead of profit, the correlation coefficient will, and then you have 3 options: increase, decrease, or stay the same. And
now I see an error. It should be revenue instead of yield, not profit.
It's all good. It's all good.
Yeah. So revenue instead of yield is a typo there.
Okay.
So, yep.
And then the other one has to do with modifying the x-axis limits to the greenhouse models app. When is a linear regression model a good fit for this data?
Having trouble getting out of here. There we go. So again, one thing you notice is when we go to this shiny app, as you're thinking about those questions, this is a sample class data set that some people use for the data. So it's just a sample data set, but we have X variable water, we have yield here. We've added a linear line. And when you add a linear line, we have our output, which can be hard to read, but we try and give instructions. If you're not familiar with this, where is the y-intercept, where is the slope, where's r squared? So if you can find the correlation coefficient, if you know where r squared is, can you find r? Those sorts of things. So we try and highlight, even if students aren't familiar with this software, what they can do with it. But one of the questions we're looking at, is if we change this to revenue, which is 4 times yield, how did that graph change? We use revenue here, which goes from 0 to 80 versus yield that goes from 0 to 20. And when you look at this, hopefully you can see that, Mary, did people, and the other thing you can do is you can adjust these limits here. And as you change this, like if I change this to 31, I get a much higher R squared value than I did, or a higher, not much higher, than if I did this approach.
I'm going to end the polling now, okay?
Yep. And if you could read the results off, that would be great. Or just, summarize the results for me.
So the summary shows most that either stay the same or increase for the first question. And for the second question, The majority was X is less than or equal to 30, and then less than or equal to 25. And then the last, a couple of believed X is less than or equal to 35 was a best option.
Yeah, and so this really starts getting into the decisions. Now, if you're a farmer, if you're going to make this, if you want to make the most money possible, this limit, this access looks pretty good. So one of the questions down here that gets a little more challenging is, well, maybe we should just throw some of the data out. If we throw some of the data out, now we have a really good regression line. Our R squared is even better. Is that what you'd want to use to optimize profits? And, students like to throw out data if it improves their R squared value. Why is that a bad idea here? And hopefully you can see that it's a bad idea because you lose information that's telling you the truth about what's happening here. We see that where you can optimize profits and the linear line works fairly well at the beginning, but we can't extrapolate too far, if we're using this line here. In this case, we still get an R squared of 91%. Your correlation is the square root of 0.83 is 0.91. So you get a correlation of 0.91. So even though you have a really good correlation, how would you optimize profits here? Would you use this line? How well does it predict when water is 20? How well would this predict when water is 80? And it's very practical to students, and students can comprehend really quickly, well, if I add too much water, maybe it's going to hurt the crops. So we can try different models in here, quadratic models, and we can see the different equations, but this first page doesn't really do that. It just asks, does a linear model work well or not? And we can go down into this next set of questions here, and it's exactly the same data, but now I'm going to add another data set. I'm going to add sample 2 to it. Okay, it's a lot messier. They didn't necessarily follow the instructions, but look what happens. Does that straight line work very well now? And now our correlation isn't nearly as good. What happened to that? Why is that the case? How does that help us with interpretation? So finally, when we get to these questions, we ask, here's what I ask students to do to see if they really get a concept of, a linear line could have great statistics. You can have a very small p-value if you're doing hypothesis tests, but I say use the same group ID, but just add a 2 to it. So going back here, and I'd like you to try this because I think it's kind of fun. So we go back here. I'm going to use my same, that was a player ID I used. And now I'm going to use AMATYC 1, and I'm just going to add a 2 to it. And I'm going to play level 1 again with this new group ID. Okay. And now I'm going to pick in here what I think will make me the most money. Based on what you've seen so far in the graphs, how would you, and you're going to make the most money possible, what are you going to do? Go ahead and play the game, and I want to see who makes the most money. So again, you probably want to stick with corn because that's the only place we've had data, but choose anything else you want here. Okay, go ahead and do that. I'll give you a minute. Okay, so you note here, I have a note in here. Sometimes it can take up to 60 minutes for your class data to show up in the app. So we don't necessarily have all of it, but the AMATYC 1 data has shown up. And if you look at that, you can see, we can say overall money. So some corn farmer came up with, they earned $204. VC3, OC3. And someone wrote in the instructions, not my name. So we have a lot of people who use not my name. So maybe we want to remove some of these people. So we could say, I just want to compete with these people. I don't want to look at everybody. So if I just look at those people, I can see where I fit among my teammates. So a great question is, if all these students followed instructions, why are we getting such different profits? And so we can look at that, or we can look at seasonal profit. You can see some people lost money, some people earned money. And maybe they didn't follow instructions quite right. And hopefully you can see how this is a little bit of a sense of a competition using the data, but also using common sense. We don't trust models blindly. So even if we have a good statistic, if the correlation is really strong, it doesn't necessarily mean it's a great model. And I'm just going to really quickly show you that that's page 1. What we did right there is page 1. Part 2 gets into a little bit more details where you can choose your group. And let's see if I can do it. So there's AMATYC 1, and it's going to take a minute to load. It's a little bit slow right now. And I want to use level 1. So there's the AMATYC 1 data. And I could, instead of looking at the x-axis, I might be able to look at, I could, facet by different things, by player ID, which is going to be too many for this group. But maybe we see, 1, 2, 3, 4, 6, 5 looks like they did not follow the data right. So I'm going to remove this person from my data set. And Aunt Jane, there might be an issue with Aunt Jane too. So I'm going to remove Aunt Jane, and maybe I'm going to remove Mel 1. And not my name, this guy with the happy face. So now if I do that and I go back and look at my data, I'm going to just not facet it anymore. There's still some people who maybe didn't follow the directions quite right. But you can see, you can clean your own data from your class and talk about what's going on with it. So level 2 is a little more advanced. I think it is still really interesting for students to follow. We start talking about what is a quadratic model and why is a quadratic model better than a linear model. So maybe you don't get that into your class, maybe you do. Okay, but so there's another option of different games you can do. And then finally, part 3 gets into a little more complexity where we can look at, do I have the data here? With some groups, you can look at all sorts of all 3 crops simultaneously. So what do you do if you have a multivariate regression analysis with different types of crops, different types of nitrates, different types of different amounts of water? And so when you have all that data in here, I think sample 2 has more of that data in here, I think. Yeah, so you can see, if we do quadratic models for different things, you can see that separating out, why do you need, a variable to indicate the type of crop, and why do you need a variable, to indicate the amount of water, and why do you need a variable to, to modify the nitrate level? So we can get more complex in here fairly quickly. But again, a lot of students just work on page 1. So any questions on that?
I don't see any questions.
Okay.
There was a question where they grew some crops and lost some money, but did not find the check your understanding to enter data. So it might have been something that was loading, or.
Yeah, so again, it can take a while to load. And this check your understanding, I only use the sample 1 group. I use this sample data in here so that everyone gets exactly the same answer. But after everyone can, I'm sure, because if everyone's using their own data, it's really hard to determine, what is the correlation, and so forth. So we have some auto-graded answers here that help students, just verify they understand the basic calculations. But then we talk about what does it mean? How do you interpret it? And then, when you go into these questions, now in App Models 2, you get a chance to update and put in your own ID. So then here we can find the AMATYC group, hopefully.
And we do have one other question here. It says, is the yield at the different levels of water based on actual results?
Yes, yes. And we talked about that up here a little bit. It's based on Iowa cropland.
Oh, very cool.
And so each plot, it represents 1/10 of an acre. And so it represents 1/10 the actual yield from Iowa farmland. So we didn't get into that too much here. Okay. So the next example, I'm going to go through fairly quickly, hopefully. Oh, just real quickly is a slideshow, some current slide. There's lots of other questions you can ask. And so I'm not going to spend time here, but you could use the same thing for hypothesis testing. You know, do you have statistically significant evidence, if you want to use the word significant or not? Is there evidence that giving water, you know, watering plants with 35 is better than 25? How would you set up a hypothesis test to do that? You know, we talked a little bit about estimation, regression, you know, or estimating in regression, and you could also do extrapolation, talking about predictions. How do you know if they're accurate? You can talk about confidence intervals and how this fits with the variability that everyone's getting. Again, talking a lot more about residual plots. The app too shows you the residual plots for the straight line, and you can see how the residuals have these weird patterns. So it's a really nice introduction to more complex models without having them really do any of the calculations, just kind of visually see what's meaningful and what's not. There's also more advanced options on that last page where you can get fairly complex regression equations. Okay, so I wanted to also spend a little time talking about a data journalism story. And again, one of the key things here is we wanted to try and incorporate research ideas while easing the workload of faculty. So we start with an introductory article that's really easy to read. Again, everything has 3 pages, pages 1, 2, and 3, where the first page is very easy and the following pages get more complex. We have interactive apps that investigate claims about each one of these topics. And then we provide additional discussion questions that get into more complex interpretations and, you know, really storytelling with the data. So the first article, the only article I'm going to talk about today, is the NYPD stop and frisk data. So in this data set, we're looking at exploring racial disparities in New York City. So this data contains every single police report for the last, I think, like 16 years. So we can look back and see every single police report. If someone was arrested, if someone was stopped, were they male, were they female, what was the race of the suspect, and so forth. Okay, so our first question that we ask students, and just say, we make a claim, there's evidence of racial discrimination in the NYPD police data. Okay, and so we talked about this. Every year we collect stops. We talk about it being a proven law enforcement tactic is to have this stop and frisk policy where we stop people because they look suspicious. But in recent years, the NYPD was highly criticized for these stop and frisk policies because they tended to be that what they were claiming is that they were discriminatory in who they actually stopped. Okay, so I showed this graph in the class, and this is the actual data that students are going to see in the app, and it's a bar graph representing the total number of people arrested in New York by race of the suspect. So you can see over these 10 years, this 10-year data set, you can see how many Asians and well over 100,000 Blacks, Hispanics, Native, and white. According to the police reports, does it look like there's evidence of racial discrimination? Now, one of the things you should think about is, well, what is the racial distribution of the city? There are more white people in New York than any other race. You know, so again, does this show evidence of discrimination? But another way to look at exactly the same data is this. And this is, once you are stopped by the police, what is your probability of being arrested? The percent of people arrested by race given that they were stopped. And if you look at this, about 6% of the people that were stopped were arrested. So does figure 1B, my question is, you know, figure 1A shows that about 50% of all arrests made in New York were involved a black suspect. Figure 1B shows that over 6% of Asians, Hispanics, and whites are arrested after they're stopped. So which graph is more appropriate to use? Is figure A, 1A or 1B more appropriate? And so that leads to some really good questions for the students. just thinking about, the core issue is making sure you understand what conditional probability is. Both are correct, both are accurate, but they tell very different stories. And I think both data sets tell us something. And so the students, and we discussed this in the class, that here, this shows clear evidence that there are some discriminatory patterns going on in New York City. However, this shows that many police are not discriminating on who they arrest, given that the person looks suspicious. Now, again, you can read a lot into that, and there's a lot of great discussion that can go into that. I tend to tell the students, just tell me what the data says, not your what does the data actually tell us? Should we be concerned? Yes, we should be concerned, but we have to take into account that maybe it's a systematic process and maybe not an individual case that every police officer is being discriminatory in their patterns. Another claim, so that was the first page we talk about. On the second page, so after a 2013 court ruling, there's been a reduction in the racial disparity by police stops. So the courts decided that there was some discrimination going on with these stop and frisk policies. And Mayor Bill de Blasio in 2014 made this stop and frisk reform a central issue in his campaign. And shortly after his election, he moved aggressively to honor his campaign promises. So here we have the same data, but we faceted by year. So if I look at 2006, 2007, 2008, and again, by race. I'll go previous here. We can see that the number of people stopped has decreased dramatically in recent years. And it stays this way from, I think we have up to 2019 data actually in our data set now. Does that mean that the racial discrimination has stopped? Let's look at, here, let me hit the next one. This is 2016 data. If I just look at 2016 alone, even though there's a reduction in the number of stops, the patterns are still existing. So did stopping the stop and frisk reduce the racism that's occurring in these stop and frisks, or in the NYPD? So the key idea here is data can be easily manipulated to support a particular preconceived notion. Summarizing a complex data set with only one graph or one hypothesis test can easily misrepresent the true patterns within the data. So our goal is to teach students, instead of looking at the first Facebook, message they get, objectively look at the entire data set before drawing conclusions. And so I wanted to go to this actual website and show you how to do that in this page. So if we go to the NYPD site, my internet's a little bit slow right now. I'm going to share this in chat. But what you see here is a fairly easy to read story where we go through these two graphs, and talking about how percentages can be mathematically accurate, but lead to very different conclusions. But then students get to go and look at this graph right here, where they can select the year. So maybe I want to look at, 2006 to 2016, or maybe I want to look at just the most recent years. And I can look at number of stops by race. I could look at the number frisked by race. I can look at the number of arrested by race. And maybe I say, well, I am not interested in the other group. I've removed some of these other ones already in here. And maybe I just want to compare a few groups. And maybe I only want to look at males, or I only want to look at females, or I want to look at a few crime types. So I can change that in here. But either way, I can just refresh the page to go back to the standard. I have suggestions, let's look at arrested. We can go by race. We can look at just the total counts, how many people were arrested in this time frame. And we can see, I'm going to zoom in here a little bit, that about 80,000 Blacks were arrested in this time frame. But if I want to do it percentage of stops of the people who were stopped more recent years, it seems like, if we look at this, given that you were stopped, it's more likely that a white person was arrested than a Black person. I may also, and what this app does, again, we have very guided questions in here where we show students how to manipulate these graphs try a few changes in here. You know, what is the approximate number of Black people who have been arrested between 2006 and 2018? So I can change this, you know, variable here to 2006 to 18 and see just the counts, the total number of Black people that were arrested. You know, estimate the number of times that police reported frisking Black people between 2015 and 2018. So I can change my, you know, x-axis in here and change it to frisked. You know, compare the percentage of people stopped who were frisked in certain years. Or, for example, here's another one I have a question for. In 2018, what suspected crime type had the most frisks? So I could look at frisks, and instead of looking by race, and let's look at all our data maybe. Oh. I can look at crime type. And if you look at this, we can see there's assault, other, substance theft, trespassing, and weapon. And if we look at that data, we can see that most of the frisk cases came when people were thought to carry a possession of an illegal weapon. And these variable descriptions are listed in here too, and you can get those you know, but it's really fun because what happens here is students can create all sorts of questions that they want to ask. Let me go back to my PowerPoint a minute. So we could see in our previous question here that possession of an illegal weapon was much more likely than any other cases. And again, we can go on to the next pages where it gets a little bit more complex in each one of those activities that we can go through. For example, you know, this is page 1 where we're just looking at bar charts, and we can change bar charts based on percentages so we can see, you know, so many different questions that are going on. So we may look at crime type, and we may want to facet by gender, meaning we make a separate graph for each gender. You know, most of the people were male versus female. Maybe we don't like the facet option, and we can color by gender. And you can see here that, you know, very consistently, there's more male for each crime type, you know, than females. Let's change it back to number of people that were actually were handcuffed. You know, fewer people were handcuffed, and let's facet by year. What do we see here? You know, we didn't have a lot of data in 2005. The data set isn't quite complete there, but you see this pattern that's decreasing, that there's fewer and fewer cases. So maybe we want to look just at the 2019 case. And again, we see many more males in each one of these. We could look at this, and then we could facet by race. And again, you can see Black, Hispanic, and white, and you can see dramatic differences in these in more recent years as well. How does 2009 compare to 2000? Let's go to 2006. I trust that data just a little bit more. You know, there's more here, but the patterns are very similar. So I would encourage you, all of these things are freely available for you to use and to try in your classes. And one other aspect is you can just download, and if you hit this download button, you will download the data set into a CSV file. So you can easily download and access the data that we're using for these graphs, put it into any software you like if you want students to do something differently. Also, you know, we have a part 2 and a part 3. Part 3, again, looks at spatial statistics. So we have these nice visualizations, and you can look at the map under different conditions there. You know, so we can look at the racial distribution by year, let's see, and by number of arrests, by, you know, which, you know, just a wide variety of different options here too that you could try. You can look at outliers and unusual data. Okay. So I'm listing here, and I'm running out of time, so I'm not going to go through them in great detail. But we can see, you know, that there's lots of different questions that students can ask based on this data set. And it's really fun to have students just give a one-page presentation with a graph they pull from the data set to get a view of what the data looks like. And just really quickly, I want to summarize here. I'm a big fan of Dick DeVoe, who talks about, students can do calculations. You can ask them to calculate a percent, but interpreting that percent can be much more difficult. And so, I pulled this from Dick DeVoe's talk in his research paper called Math is Music, Statistics is Literature. But we also talked about the tyranny of the technique. Students want to focus on the calculations because they know they get it right. And Carol Dwork, I really like her work as well, that talks about students can learn to think critically and not really focus on the calculations as much as really thinking, what does the data truly tell us? I like to think, these are common sense questions. How do you use common sense in there? And that deals with uncertainty, it deals with abstraction, it deals with much more than a mathematical formula, but thinking differently. And so I might see myself in these activities to coach students to think creatively and critically and give them time and space to explore questions and ask, and look at unique approaches to the data set that's available. What can they find? What patterns do they have? Does it agree with what other people have written or thought? And can you find the same data set showing completely different patterns, conflicting results? When does this happen and why? So I'm going to end there. I did want you to know that we are looking for class testers this spring. We are testing the greenhouse game. And to be a class tester, you have a pre and a post survey that's completely online. We ask you to have your students go through the greenhouse lab where they spend 10 minutes, maybe on one class period where you demonstrate the app to them to show them how to do it with the tutorial. They do steps 1A and steps B, which is collect their own data and then look at the sample data. And then in day 2, we give them the discussion questions to answer and some challenges and some games to be involved. And then they do a little post survey. We have some funding from the NSF to support you if you're willing to do this class testing. Please just send me an email if you're interested in that. And again, just thank you for spending time, taking the time in your busy day to listen to this talk. And I'm willing to stay on and answer any other questions if people have some.
Thank you, Shonda. Can I ask you to stop sharing your screen?
Yes.
And why don't you go ahead and type in the chat the link if you'd like, or your contact information if you'd like to do that.
Yeah, thank you.
And I am just going to share the last little bit of slides that I have because I forgot to do it. So yay. So let me do that. So I just wanted to remind everyone that the views expressed by the presenter or presenters are not necessarily the views of AMATYC. Commercial products mentioned by presenters are not endorsed by AMATYC. And we of course thank McGraw-Hill for their support of the 2022 AMATYC webinar series. Thanks for signing up for today's AMATYC webinar. If you'd like to support future AMATYC webinars, of course, please join AMATYC, and I can actually put this in the chat as well. And additionally, we have some additional professional development opportunities. We are going to be in Toronto, hopefully, for our conference. And finally, of course, this recording will be posted to the AMATYC webinars page, hopefully within the next 2 weeks or less. I have hope for that. And so let me go ahead and stop there. I also wanted to, let me stop sharing, put in the link for you to complete the survey for this webinar. So let me go ahead and put that in the chat real fast. And if you don't get that, or if you have to leave, no worries. I will be sending a follow-up email to everyone. So again, thank you, Shonda. And I don't think I see any questions.
Yes.
And there's nothing in there. Okay, cool. So I think we're good. So yes. Okay, Cool. So
Great.
let me stop recording because we want to do that.